My name is Zachary Owaki, and this is my reassessment for the work energy wheel system standard. On the left hand side, I just have my values in a small diagram for states 1, 2, and 3. Part A is with a point particle system. I chose Tarzan as my system. So from state 1 to 2, him hanging to just before his feet touch the ground. The work equals change in energy. Work will be work done by gravity. Change in energy should be kinetic. Initial kinetic energy should be 0 since he's just hanging. So mg delta y equals half mv2 squared. I solved that algebraically for v2. Plugged in my values and got his velocity just before his feet touch the ground is 6.41561 meters per second. So with the extended system, I chose the same system, Tarzan. Work equals delta E change in energy. So same thing except plus change in internal energy, and in this case it's going to be negative minus 1/2 mv2 squared since it's from state 2 to 3. So I plugged in my values and got change in internal energy is 3038.3 joules. So with this one I interpreted B as just before his feet touched the ground, meaning there was no work done by the ground itself because his feet haven't touched the ground yet, which would mean the only work should be by gravity. But if we were to assume that there was work done by the ground, instead it meant when his feet did touch the ground to that crouching position, then I would just have to find the work done by the floor, which I'll just do like this, finding out the force done by the ground, plugging in my values and getting that the ground did negative 7,840 newtons, and plugging that in here to find change in internal energy, which I didn't actually have to find the force, I just had to find the work done by gravity. But I can just plug those things back in and get change in internal energy would have been 0.002584 joules. But how I interpreted the problem was as state 2 being just before his feet touched the ground means there's no work done by the ground, meaning change in internal energy should be 3038.3 joules.